Okay, in question 5 we have a 78.0 kilogram scuba diver jumps from a boat and enters the water with a downward velocity of 0.95 meters per second. She descends to a depth of 5 meters with constant acceleration, where her velocity reaches 1.70 meters per second. Calculate the acceleration of the diver. Okay. It's a funny question, isn't it? Calculate the acceleration of the diver downward velocity with no. She descends to a depth of 5 meters with constant acceleration. Oh, right. Calculate, and she reaches it there. So, what have they given us? We have mass, and we have our initial velocity. Enters the water with downward. Yep. Okay. And then we have the s here, and we have where her velocity reaches 1 point. Okay, v. Good. Okay. So we're looking for acceleration. So this time we're going to use. Sometimes it's good to say what you actually have, so you can figure out which one we're going to use. We have velocity, final velocity, initial velocity, and we have the displacement. Okay, so we're going to use this equation here: v squared equals u squared plus 2as. Let's go back there. V squared equals u squared plus 2as, and we can rearrange this one, or you can enter in the numbers. We might as well just enter in the numbers straight away. So we have 1.70 squared is equal to 0.95 squared plus 2 times by a times 5.0. Okay, so we're going to end up with 2 times 5 is 10. So I'm going to just rearrange this now for a. So a is equal to 1.70 squared minus 0.95 squared, all divided by 10, or 2 times 5. Quite a challenging problem for one marker, actually. So anyway, we get, let's put that into a calculator. 1.70 all squared minus 0.95 squared. Okay, execute that now. 1.9875, and then divided by 10 is going to be 0.19875. So I'm going to say that's equal to a is equal to 0.199 meters per second squared, and that is downwards. Down. We'll just say down. Okay, gee, it's not very good handwriting, is it? Let me make that a bit more obvious. A. My A's and 9's sometimes look very similar. So A is equal to 0.199. I'm going to make that a bit more clear. Sorry, just bear with me a second. That looks a bit better. Okay, meters per second down. Second square down. How long does it take her to reach a depth of 5 meters? Okay, so we have all these ones. So I'm actually going to use, the easiest one to use is v equals u plus at. I think that's the easiest one to use. Because now we have the acceleration, so we can have v, which is 1.70 equals u 0.95 plus 0.199t, and again we have t is equal to 1.70 minus 0.95 divided by 0.199. I'll use bracket this time. 1.70 minus 0.95 divided by 0.199, which is equal to 3.77 seconds. Okay, so a lot of rearranging in this one. Calculate the buoyancy force, the buoyant force, upwards force of the water on the diver. Okay, that's a challenging question. So if we have a diver and they are 78 kilograms. So we have the force of gravity, Fg, which is equal to mg, right? Mass times gravity. And then we'll have a buoyancy force, which I'm going to call it Fb, buoyant force. And the net force is going to be equal to the gravitational force minus the buoyancy force. So we have F net, I'm going to say downwards is positive for simplicity, is equal to Fg minus Fb. Okay, and that means that Fb, which is what we want, is going to be equal to Fg minus the net force. So we swap those around. And we know what mg is, that's 78.0 times 9.81 minus Fnet, which is also 78.0, times by the acceleration that we are experiencing, which was 0.199 meters per second. Okay, so the difference is, let's have a look at these differences. Another way we could have done it, 78.0, I'm going to take that as a common factor for the calculation, 9.81 minus 0.199. So the buoyancy force is 749, I'm going to round that up, 750 newtons. Okay, 750 newtons, good. Okay, we'll do question 6 quickly in the next video.